Alright, in this video, going to learn how to use the periodic table to do electron configuration for us. Basically, how to read the periodic table. So, in order to start this, let's get our rows. Oops. And put our, first of all, we'll just number down the side 1 through 7. And as you are doing on the past couple pages, getting acquainted with everything, is that if you look at this first column, right, hydrogen, lithium, sodium, and down the line, what does their electron configuration end with? Right, everything here, its outermost electron ends in an S1. Likewise, if you do for group 2 here, everything here, its final electron is S2. And there's only 2 electrons that can fit in a sublevel, and these 2 columns are referred to as the S block. Everything in this first column, its final electron is 1s. Everything in column 2 or group 2 is 2s. So we can use that to our advantage when we're trying to figure out. So that's the S block. So everything here is filling, in this first row is filling S1, here is filling S2. Now let's jump over to this side of the periodic table. And if we look in this column here, what do they all have in common from their electron configuration? Is that you'll notice these all end with their outermost electrons being a P1. And if we look at how many columns are in this little area over here, blue, notice there's 6. Just need to color this one purple because really electron configuration wise should be an S block. But it's over on this side due to chemical properties. So we number across the top here 1, 2, 3, 4, 5, 6. This is referred to as the P block. Just have to remember that what energy level does the P sublevel first show up? It's 2. So this row would be filling the 2P, this row 3P, 4P, 5P, 6P, and 7P. So we'll just color this blue. I don't think anyone can color as well as I can. So again, everything in this column ends in a P1, in the second column P2, P3, P4, P5, and finally P6. So if we look smack dab here in the middle, we look at this section. If you count how many columns are in there, number across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, this is the D block. So everything here ends in a D1. Everything here, D2, D3, 4, all the way to D7. Now, the key thing to remember here is that what is the first energy level that the D block first shows up in? And if we go back to page, what notes is that? We're going way back. Notice here, the D sublevel first shows up in the 3rd energy level. So right here is filling 3D, this is 4D, 5D, and 6D. Just have to remember that even though it's in period 4, which for the S and the P mean that it's the 4th energy level for the S block and P block, the D is one behind. So it's 3D, 4D, 5D, and 6D. So we'll do some nice coloring. Lastly, down here, I just have to cross out this last box. It should be there. And the only color I have left is orange. And if you were to count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, oh, lo and behold, this is the F block. Now, going back to our notes on page 9, said, where does the F block first show up? Well, in energy level 4. That means this is filling the 4F, this is filling the 5F. And likewise, because this is considered energy level 4 and 5. Not period, because that's completely different. Now, just make a comment here. You cannot write 3D, 4D, 5D, 6D on your periodic table that you use in class, 4F, 5F. You can't write these 1 through 7. That is primarily what I see, though, this unit is that people on their own periodic tables will write that on there and then want to use them or attempt to use them on any test or quiz over this content, which clearly is an advantage. So again, I do not want to see you trying to use a periodic table that has this information written on it on any test or quiz for this unit, especially even this over here. Okay, just a heads up, just don't do it. If you've got that stuff written on your periodic table, use an in-class one. You know, if I go around checking things and I notice that you do have those writing there, you know, you will get a 0 on that quiz, because that's cheating. Right? You don't need to do that. If you know the layout of the periodic table, then you're good, because hopefully, you know, this makes sense to you. 2 electrons in the S block, 2 columns. 6 electrons in the P block, 6 columns. 10 in the D, and then 14 for the F. And then you just have to remember, again, from page 9, the S first shows up in the first energy level, the P in the second, the D in the third, and the F in the fourth. Now, how do we use this? So on this example here, silicon, its atomic number is 14. So we have to place 14 electrons. And we can just read our periodic table, always starting up here at hydrogen. So remember, hydrogen is filling 1s1. And if you go straight across the table, then you have helium over here, that's 1s2. So we're just going to read this periodic table, kind of rastering across until we end up at our element, in this case, silicon. So starting up here, this fills 1s1, this fills 1s2. We have to ask ourselves, are we at silicon yet? No. Okay, so I will write down 1s2 down here, and we'll come down to the second row. Now keep in mind, silicon on this periodic table is right here. So that's where we want to get to. So starting here, this is filling the now 2s1 and 2s2. And so for right here, are we at silicon yet? No. So we're going to write down 2s2 down here and keep going. We jump across the periodic table. Now we're into the P block, the 2p block. So once again, if we are filling 2p1 here, P2, P2, 3, 4, 5, by the time we get to neon here, we've filled 2p6. Ask ourselves, are we at silicon yet? No. So I write down 2p6. Jump down to the next step, and I'm in the 3s block. This fills 3s1, 3s2, still not to silicon. So I write down 3s2 here, and jump across to the p block, and silicon is right here. So this is now filled to 3p1, 3p2, and I'm at silicon, so I just write down that partial 3p2, and we're done. Okay, now go on to this next one, ruthenium. Ruthenium is number 44. That means it has 44 electrons, and that's also on the table. It is 1, 2, 3, 4, 5, 6. It is right here on the table. So right off the bat, we know that the final electrons in ruthenium are going to be 4d6. And so we just have to go and fill everything before that. Again, starting at the top left with hydrogen and just reading across. So this first thing, 1s1, 1s2, we're not at ruthenium, so we write that down here. This is filling the 2s. We're not at ruthenium when we get to here. Jump across. 2p1 through 6. We're not at ruthenium. Jump down again. 3s2. Then 3p6 when we get to argon, still not a repeat, so we've written both of those down. 3s2, 3p6. Jump down to the fourth block, or the fourth period, and we're filling the 4s2 here. Still not at a ruthenium, but now this is the first time we've entered the D sublevel, and now it's the 3D. So we go all the way across. We have not reached ruthenium, but we have filled 3d10. And now we've jumped now into the 4p block. And by the time we get to here, we have not reached rutheniums, but we have filled the 4p block, so that's 4p6. And we jump down once again to the 5d. Get some focus. Looks a little better. 6. We jump down to the 5th energy level, or the 5th period. That's filled 5s2 when we get to here, so we write that down. And lastly, now we're into the 4d. 1, 2, 3, 4, 5, 6, and that's ruthenium, so we write down 4d6 down here, and we are done. Okay, so I'd like you to try uranium here. Pause the video and try uranium. Again, this is one of the biggest on the table, so it may take you a bit, but if you can do something like uranium or something like that, that is in the F block, then you know how to use your periodic table, and you can use that. Okay, so I'm just going to write the answer here. Hopefully you've P6, 5s2, 4d10, 5p6, 6s2, 5d10. Nope. After the 6s2, go to the F, 4f14, 5d10, 6p6. And it's so long I've got to come down here. 6p6, 7s2, 5f, and uranium is right here in box number 4, so 5f4. So that should be the electron configuration for uranium. If you count up all these exponents, it should add up to 92.
Now, as you noticed with the uranium, that is a nightmare to have to write out. Would you want to sit there and write out electron configurations all day? No. So a shorthand notation or abbreviated notation was developed using the noble gases as basically placeholders. So you find which element you want the electron configuration for, and to do noble gas or shorthand notation, you then have to figure out the noble gas that came as, right before that element. So in case of chlorine, we're looking at chlorine. Chlorine's here. The last noble gas that we passed, so to speak, on the way to the electron configuration of chlorine was up here, neon. So we're going to use that as a placeholder. So what we do is we put neon in brackets. And what that symbolizes neon encompasses the 1s2, the 2s2, the 2p6. So the neon is taking place of that. And now we just have to fill out the remaining stuff to get to chlorine. So if we're starting with neon, then it's just 3s2, and lastly 3p5 for the chlorine. So did that save us a whole bunch of writing for chlorine? Some, not a crazy amount, but it's better than nothing. Barium, if we want to do that, we first have to find barium, and on the periodic table it is down here. So we have to look at what noble gas we have passed most recently, and basically up and over we see xenon. So we would write down xenon in brackets, and then we just have to fill in what's ever missing. So if xenon's here, that's filled the 5p6. Barium, we just have to come down to now the 6th energy level, and it's 6s2. And that is a lot shorter. Okay. One question people may have when we're doing this is, if we're doing the noble gas or the shorthand notation of a noble gas, can we just write its abbreviation? No, technically. If we wanted to figure out the electron configuration of neon, let's say, well, if we wanted to do the shorthand of that, we'd have to go to the prior noble gas, which would be helium, and then do 2s2, 2p6. So a noble gas cannot be its own shorthand. Last example here we have is rhodium. This is rhodium. So it's right here in the D block. So all we need to do is go find the last noble gas, which in this case would be krypton, and fill in everything past krypton until we get to rhodium. So krypton is filling 4p6. We just have to add 5s2, and then the D sublevel. Remember, this is not 5D. This starts 3D. This is 4D. So this is 4D. 1, 2, 3, 4, 5, 6, 7. And there would be rhodium. Again, that's pretty good. Much more convenient.